Separation of variables. This involves rewriting the equation so that each variable occurs only on one side of the equation. You can then integrate each side to find the general solution. So what we're given is a differential equation, and we're trying to find that original solution. Here I've got y prime equals, there's my differential. I'm wanting to find y equals. Okay, so I'm wanting to find that original equation. When we integrate, some of the things that we want to remember about integration is if I have x's up through here, I'd have a dx on the end. If I had y's through here, then this would be a dy. It doesn't matter what variable I had. If I had a w, dw. We've seen theta. If I had thetas in the integral, d theta. The key is the variables have got to match. So whatever variable I have in my integral, it's going to be d of that same variable. So a lot of times differentials are presented like this, where it's y prime. I usually like to rewrite them as dy over dx if they're not already written this way. So if I rewrite that as dy over dx equals 2x over y, then I can see I've got y's and x's, dy's and dx's. So the separation of variable part means I want to get the y's on the same side as the dy's. I want to get the x's on the same side as the dx's. So on this one, I can simply bring the y over to the left side, multiply both sides by y. That'll give me y over here, dy, and then I can multiply this side by dx, and I have 2x dx. Now I'm set up for the integration. If I look at it, I've separated the variables. I have the y's sitting with the dy's, x is sitting with the dx. And now I can integrate both sides to find my original general solution. So if I integrate y squared over 2. If I integrate 2x, the x squared would be 2x squared over 2, but the 2's would cancel. And then remember we have that plus c. So technically there is a plus c on both sides. Right? So I'm going to just write it up here for a second. Technically we'd have a plus c, x squared plus c. So a lot of times when you see it written out in the textbook or what have you, you'll see do like a c1, C2. We don't know what the constants are, but we have no idea if they're the same constant. Right? And then all of a sudden they'll skip to this and just do a plus C. Because if you subtract C1 from C2, it's still C. If you take a constant and subtract it from another constant, it's still a constant. Not going to change anything. So usually for me, I just go ahead and skip this intermediate step and just go plus C, and I put it on the right side because I'm used to putting it on the right side. It doesn't matter which side. Technically, once again, there's one on each side, but they're going to combine in the next step to create one. And sometimes they'll put like a subscript of 3, but the subscript's not changing anything at all. Okay? So we're going to get our C's combined. This is correct. We need to understand that this is correct. We're going to see some different forms. One of the things that we need to make sure we understand is that we originally had y prime, differential of y. So my original general equation would be y equals. So I would need to solve this for y. I have correctly integrated it. There's nothing wrong with that answer. But most of the time, you're going to be asked to solve it for y to find that original, and I need to make sure I'm practicing that. So pretty basic here. I can multiply everything by 2. That'll get rid of the fraction. So if I multiply by 2, I'd have y squared equals 2x squared plus c. And again, just a c. There's no need to write 2c because 2 times a constant is still a constant. It's not changing that. So we still just have a c value. And then my last step here, y would be square root 2x squared plus c. to get rid of that square piece. So that would be correct. Some other ways that we could see it. It's possible maybe they decide, hey, we want x's and y's on the same side. So it's something like a y squared minus 2x squared equals c. Have something like that. Just remember there's some different forms. We need to be comfortable going with whichever form we're presented with. Let's look at this one. Let's go y prime equals x over 1 plus y. Y prime is x over 1 plus y. So again, my suggestion would be take the y prime and rewrite it as dy dx. It's not required, but then you can actually see that dy and dx sitting in there. It helps you out. And so I again can multiply over 1 plus y dy equals x dx. If I do that cross multiplying. So I'm integrating both of these. So I would have y, integral of 1, plus y squared over 2 equals x squared over 2. And then there comes that plus c. Again, really a plus c on both sides. I'm just going through and combining them. On this one, there's no way in this particular situation I'm going to get y alone because I have more than one y with different powers here. So I'm not going to be able to do something like this I did in the last one. I could get rid of the fractions and have something like a 2y plus y squared equals x squared. And then remember, just begin plus c. 2c is still just a constant. But there's not much else I can do there. I could bring the x squared over. That would be about it. Some of the things as far as writing it a little bit differently, when you see both of them squared, that's one of your old, that would be, in this case, a hyperbola, because it was subtraction. So to give you a different look on this one, again, our focus is getting to here. We just need to understand some of these different looks. I'm actually going to switch up the y squared and the 2y, put the y squared first, and I'm going to complete the square. So half of 2 is 1, square is 1, so I'll add 1, then I'll subtract 1, equals x squared plus c. So we've seen this where we're kind of keeping the balance there. Here you'd have y plus 1 squared, minus 1 is x squared plus c, which means y plus 1 squared equals x squared plus c. Again, if I add 1 over here, c plus 1 is still c. Correct? There's another form of it. Maybe we put them on the same side. Y plus 1 squared minus x squared equals c. Okay. I think we're going to run into a situation here for most of us where the separation and the integration, not too bad, pretty much what we're used to. We know how to get, hey, y's and x's together. The integration piece, there's nothing new as far as taking the integral. I'm getting these pieces here, or right here. Where we are possibly going to struggle some is simply the different forms that it may be written in. Again, I get this answer. How in the world did we get this? And that's just back to grinding some different things out and kind of looking at it. Do something like this. Get a different look here. Let's see, number 3. Let's go y prime equals 3x squared y. Product over there. Again, I'm going to switch to that dy dx. Now I need to get the y with the dy, the dx over with the x's. So I'm going to divide the y over. So I would have dy over y equals 3x squared dx. So I multiplied the dx over here, divided both sides by y, and I'm going to rewrite this a little bit. It's really 1 over y dy, 3x squared dx, and there's my integral. Now, one of the things that happens in this problem when you look at it is that 3. It doesn't matter if you leave the 3 with the x squared or you bring it over with the y and you're dividing by 3y. You're going to get the same answer in the very end, either way. Typically for me, I'll like leaving constants in the numerator. So if it's over here on top, that's where I'd rather leave it, as far as that's concerned. That's something that will help me going forward, kind of keeping things together there. I integrate ln, absolute value of y, this would be x cubed plus c. So again, remember, c on each side, I just combined them together. X cubed, because I'd have 3x cubed over 3. 3's cancel. And there's our natural log of y. Now, correct. Nothing wrong with that. Let's look at some different forms, though. I'm just going to rewrite it up here. Same thing I had below, ln of y, x cubed plus c. Now, if I wanted to get y alone, remember our base is e. So this would be y equals e to the x cubed plus c. Now, I no longer need the absolute value because it's not in the logarithm anymore. So that's technically why I dumped that. And then this will become y equals c e to the x cubed. So there is that growth equation. There's that exponential growth that's coming out of this integration piece. Now, as far as where that came from, just to kind of remind you here, let's look at this guy right here. This would be e to the x cubed times e to the c. Remember, if you have a sum, you had like bases, they would add. E to the c is c. I don't know what e to that c is as far as a value, but I know it's still a constant. If c is a constant, e to the constant is still a constant. That's the way I'm looking at it. There's that c in front. Now, obviously, given the old growth and decay stuff, this is the more common way we'll see it. Okay? As far as in the integration, it came out of an ln. Pretty basic integration here. We didn't do anything special right here to get to this. But the leap from looking at this equation, or even like this, to here, that's kind of tough. We got to work through the process. I got a natural log, and then I got y alone by moving that e over. That's what happened there. Let's look at a different one like that, or similar to that. Let's go y prime. Let's see, this would be 4. All right, y prime equals, let's go x times 2 plus y. Something like that. Again, I'm going to go dy dx. Now, I could do a couple things here. One, I could distribute the x and get 2x plus xy. The problem with that is now you've created a sum that you're going to have difficulty separating. So I would rather leave it as a product, because then I can bring this 2 plus y over here. So I would have it as 1 over 2 plus y dy, and take my dx over x dx. There's my integration piece. I go through, integrate both sides. I get a natural log on the left side again. I get a quadratic over on the right side. So I'm going to have ln, absolute value 2 plus y, equals x squared over 2 plus c. Right? Now be careful when you see something down there with the y. 1 over y, well, yeah, that's a direct natural log. Remember, technically this one would be a u substitution. So I need to think ahead. I left right to here because I see that y is just a power of 1. Here u is 2 plus y. du is dy. So we're matching up just fine. But if there had been something with that y, I'd have to account for it. So it is still technically that u substitution. So there's my logarithmic answer. 2 plus y, if I get rid of the logarithm, would be e to this whole thing. E to the x squared over 2 plus c. That would all be up in the exponential. And let's see, I'll just go right over here. I'm just going to rewrite it here. 2 plus y equals e x squared over 2 plus c. There we go. All right, so this would be 2 plus y equals c e to the x squared over 2. Remember, this would be e to this x squared over 2 times e to the c, and e to the c is c, some constant. So there's that exponential growth form again. As far as getting y alone, just subtract the 2 over. Like that. So I've got an exponential function. That minus 2 would mean it was shifted down 2. Something like this. Let's go. See, number, so I guess it'd be 5. All right, so y prime is 1 over x squared, y squared, and y of 1 equals 3. All right, so remember when we're given a point, y of 1 equals 3, all that's going to allow us to do is in the very end or down through there, I'm going to be able to figure out what that c is. So my first job is to kind of get this thing solved. I've got to get it separated, integrated, and I would have a plus c somewhere. That's when I can figure out what the c value is going to be. So again, I would rewrite it dy dx. I'm going to multiply the y squared over y squared dy. And that would leave the 1 over x squared over here, dx. If I multiply that dx over to the right. Now I integrate. For some of you, this looks pretty good. Others, maybe you want to go ahead and get the negative exponent in, so I'll just rewrite it. So we're going to be integrating x to the negative 2. So I'm going to integrate the left, integrate the right. I'd have y cubed over 3. Go up here, make a little space here. Let's see. Y cubed over 3 equals x to the negative 1 over negative 1 plus c. I'm going to integrate that x to the negative 2. And for myself, usually I like rewriting that to y cubed over 3 equals negative 1 over x plus c. That's more of a personal preference. But this is where I can figure out that c value. I have my base equation. I know y of 1 is c, so that means x is 1. That y value is 3, so I'd have 3 cubed over 3 equals negative 1 over 1 plus c. So let's see, that's 27 over 3 is 9. It's negative 1 plus c, so c is 10. So I do have a c value of 10 to go back and create my equation. And so my equation would then be y cubed over 3 equals negative 1 over x plus 10. And there's nothing wrong with that equation. If you want to get rid of the 3, you can. Y cubed equals negative 3 over x plus 30. And sometimes we would see it where it was taken all the way down to get y alone in this case. So y would be the cube root. Negative 3 over x plus 30. Again, any of them are correct. We're just trying to get used to seeing the different forms as far as getting a look at that. Make sure we understand that the forms can be different depending on what you're solving for. Any of these would be correct as far as what you would have.